Millions of wheelchair users worldwide are faced with the prospect of never being able to walk again. But now a US company is using a technology originally developed for military applications to enable people who can't walk to leave the confines of their chairs. I came to the London International Technology Show to see Ekso Bionics exoskeleton make its European debut.
So this is really a groundbreaking technology to help us to take simple braces to another level, motorize them and literally turn it into a wearable robot, or like we like to call it, exoskeletons. The issue of getting a person that has been paralyzed potentially for 20 years, how do you let that person send signal to the device how to walk? Here we have a robot that has to move perfectly in alignment and naturally. So the way we are doing that is actually through a non-invasive force sensors that are embedded in the crutches. So when the person moves the crutch forward, it actually sends signal to a computer that is sitting on the back, surrounded by batteries that further drive 4 motors that are sitting both at the hip and the knees. And so the opposite leg will move when you move, for instance, the right crutch forward.
The basis for the technology was originally developed at the University of California, Berkeley, as a robotic suit that could enable soldiers to lift heavy loads. Since then, a new version has been developed for use by paraplegics, something which required applying very different principles.
As we managed to build a frame that transferred the weight completely to the ground, we had a breakthrough, and that was like about 5 years ago. After that, we started really applying to it power, battery pack and sensors and other things to kind of help them to kind of get even more strength and increase even endurance. So in the beginning it was more about holding weight, but then it was more and more about how can we keep them walking for the whole day. And in this case I'm talking about the American soldier that on average has to walk maybe 20 miles a day. The difference between the military application and the Ekso is that the military one has to be much more robust. It is waterproof and dustproof. So in that case we are using hydraulic actuators, for example. In the Ekso we are using, however, electric actuators. Everything can be in a way lighter and has to be lighter. And also what is different is in terms of how it's controlled. In the military application, we are always talking about it's almost like the device is following you. It's almost like your ghost. And so it supports you. As you move, it follows you and enhances your abilities. When we are talking about people in wheelchairs, it's all about lifting them up, powering them up. So it's completely differently programmed as such.
At a cost of several $100,000, the Ekso suit will first be made available to rehabilitation centres. But the company hopes to eventually develop a more affordable version that could be used by individuals in their homes.
I always joke about it that this is almost like the first prosthetic wooden leg. Here we are really at the beginning, and it really tells you how much we can do. We have been so focused on just building a device that actually can do the basic things right now, just stand up and walk. Everything beyond this is now a possibility. Make it smaller, lightweight, create applications for stroke. At the moment we are focusing on spinal cord injuries. Create applications that can better master the balance so you can take it into people's homes. Use it in daily living during the whole day is obviously our objective. Beyond that, we look at this as an application for industrial workers, for people who are sanding and grinding and with big tools, often not able to hold them more than 2-3 minutes. If you are able to attach these tools onto an exoskeleton so that you feel it's lightweight, and that way you can increase productivity quite a bit. You can imagine also the aging population. Myself, when I will be 80 and want to go and play with my grandchildren, I would love to have a bionic device that helps me out with that instead of having that knee surgery.